Well, the leaves are turning, there's frost on the pumpkins, and there's some really cool frost on the AZEK PVC sheets that we're going to install in this episode of Building Resilience. Last time, you'll remember we were buttoning up the outside of the structure with WRBs and rain screen systems from Benjamin Obdyke. In between episodes, the guys installed the Slicker Max rain screen that'll go behind today's AZEK sheets.
If you want to get me fired up and get me super excited, bring me whatever Benjamin Obdyke has been working on in their secret lab. These guys consistently come out with some of the coolest stuff for high performance building. We use the Slicker Max, which is our ventilated rain screen. It's one of those products that we use consistently over and over and over because the ventilated rain screen is like the seatbelt and airbag approach to building, right? If somebody were to screw up the install of one of these details, which would never happen on my job, but on somebody else's job, this is that fail-safe, right? I've got air going this way and water going the other way, and it stays super nice and dry.
Maybe the coolest thing we test drove was the self-adhering HydroGap WRB, a peel and stick house wrap. Over that, we put up Slicker Max rain screen to allow drainage and drying. On the top section of the house, we used Invisorap UV as the weather barrier because that section gets an open cladding system from AZEK, which needs something durable and black behind it. The rain screen is created by Battens called Batten UV that don't compress and allow sideways air movement. Both the Battens and the WRB are highly resistant to UV degradation. We're going to work our way up to that open cladding in the next episode because today we're starting at ground level with AZEK sheets and trim with PaintPro technology. But before we cover the walls with board and battens, before we even put up the rain screen, in fact, we need to address the base of the wall where formerly there were water problems. The foundation on the addition was poorly executed and quite frankly kind of screwed up.
So whoever built this they screwed up.
See? They really screwed up by channeling all the rain into the wall. OA decided to build out the base of the wall to mimic the built-out base of the stucco sections with their signature modern flair. AZEK sheets are buried in the ground, shimmed straight, and then capped with heavy-gauge metal drip edge flashing, which is being fit by Chris. Just around the corner from Chris, Saul and Steven are leveling the last AZEK sheets and shimming them straight. Chris nails his drip edge in place, and it's time to put up the corner trims that border the AZEK sheets. These metal channels are called extreme trims from Tamlin. There are outside corners, inside corners, and horizontal channels between the sheets. This is where the top of the trim band will go, which is being cut right this minute and shapes to butt into the stucco. The boards are cut to fit tightly, so it needs to be bent out to slip into the channel of Tamlin trim. They're cut to fit tightly to control shrinkage.
You mean shrinkage?
Yes!
Which creates the most common installation error and misconception about working with PVC trim. And we got a description of how that works from Dave Parker, a technical expert with AZEK.
What people typically run into with PVC is that they install it with gaps, thinking that it's going to expand in the summer, in the wintertime, and then it's going to shrink back down in the wintertime. And what they end up running into is that the first season, it does exactly that. It expands, and they may have very little gaps in the end of their boards in the first summer. And then that next winter, it contracts. And then the next summer, it never comes back to full length again. And what happened there is essentially, within any plastic, when you go through a heat cycle, there's fibers within that PVC product that relax, and that relaxation in that PVC actually causes it to shrink slightly. One of the great things about PVC is if we fasten it correctly, we can control the movement, and we can also control the amount of shrinkage in the product by fastening it correctly, so that when that product gets heated up and warmed up for the first cycle, it actually relaxes into place with the fasteners holding it. So when you're installing, in particular in cold weather and even in the summer, it's always important even on the longer runs, to install everything tight. And all of your ends is where you want to manage your expansion contraction, so you wouldn't necessarily glue your ends on longer runs. But understand that the fastening of the product holds that product in place so that as it expands that first summer, it doesn't bow off the wall, it stays tight to the wall. And then what happens is once you go through that first cycle of warm to cold winter and then back to that next summer, what you're going to see is there's a little bit of shrinkage in that product. And what that really ends up looking like long term is you will have small gaps in your ends in the wintertime, but then in the summertime, that product will end up expanding out and being tight again.
In this open cladding system, that movement is hidden behind those metal trim channels. The ends tuck into the pockets that are about 3/4 of an inch deep. We do, however, glue the joints on long runs, and we glue the pre-assembled window trims. But before doing that, you have to open the bottle. We're going to go deeper into pre-assembling trim later because right now we're still installing that first piece of trim. These are plugs made from the PaintPro material so the painters could perfectly match the trim. Above the bottom trim band is another metal trim. This one's shaped like a Z flashing, but it's not flashing. It's an architectural element. The wall was already watertight before they installed the Slicker Max rain screen. Before we start cutting and nailing, let's look at the overall process for installing these AZEK sheets. The sheets come in various lengths, so choose one that will reduce waste as much as possible. The sheets should not bridge floors, and they should break at the subfloor level. Leave about an 1/8 inch gap between the panels and nail the edges within an inch of the edge. That way the battens will cover the nails. Batten screws should hit that gap. But before hanging any battens, trim out the windows and doors. Now you can cover each panel seam with a batten and then fill in between the battens with more battens. The battens should be spaced no more than 16 inches apart. Now we're ready to do it in the real world. They'll begin at the outside corner and work toward the stucco section. Saul and Stephen work together to transfer measurements and mark the cutouts. First, they mark the length to split that subfloor. Next, Saul marks out the window. He's kinda legendary for his expertise in cutting sheets to fit strange shapes on the first try, but this isn't really much of a challenge. When he's got his lines in the right place, he reaches for his saw and gets after cutting that sheet. You think it's gonna fit? Of course it fits. And he screws the first sheet into place. One thing about cutting PVC trim and sheet stock is all the static cling from the sawdust or whatever you call it. He's totally going to blow that scribble sheet off the panel. There it goes. Anyway, static remover spray does a great job of keeping that dust from sticking to you or your tools. On the first wall, the guys used screws to attach the sheets to the wall, but because there's a drainage mesh rain screen behind the sheets, the screws pull the sheets in and compress the rain screen. It's not a problem. They back the screws out and perfectly align the sheets. But that's why they switched to using a coil nailer with ring shank siding nails. Once the pressure is set right, it sets every nail perfect and consistent. At this point, the sheets are only fastened along the edges where battens will go later. Again, as long as the nails are within an inch of the edge, they'll be covered by a batten. Up top, the rain screen is created by the Benjamin Obdyke Batten UV, a plastic batten that allows sideways air movement. Because the batten is incompressible, they'll go back to Cortex screws so they can use the PaintPro plugs on the trim. And because this is a long piece, they'll need to join two pieces together with a scarf joint.
I'm tight.
All right. Well, I need to glue it.
Did someone say glue?
And just like that, the glue fairy shows up.
Good thing you called.
Oh, that's not the glue fairy, it's Steve Bloom with AZEK.
We've got our brand new AZEK cellular PVC cement glue applicator, which would be perfect for this job. And I see from looking at this, you've got a perfect scarf joint going, which is the best application. All you need now is a thin bead of adhesive from AZEK. and 2 fasteners on each side of your scarf joint, and that joint will not open up.
And that's the balance of the AZEK sheets and trim stock going up today. Now they'll pre-assemble the window and door trim, install them on the wall, and then put up the battens. Saul fastens the top and bottom to make sure the batten will be plumb and straight, and then he screws off the center section. They generally snap a line for tall battens just to make sure they'll be straight. And then they get after it because the sun is sinking fast. Battens are placed over every seam and then between the seams every 16 inches into studs. This is why there's no fasteners needed in the field of the panels when they're initially installed, because the battens will be placed every 16 inches and screwed vertically every 12 inches. With this wall just about complete, it's time to put the kids to work filling screw holes with PaintPro plugs. But don't worry, he's not carrying any lumber with that broken arm, or climbing ladders. We're going to do that next time when we install AZEK's open cladding. We'll take a closer look at how the system works, and then we'll test it out with a watering can. Next time on Building Resilience.